Assalamu alaikum warahmatullahi wabarakatuh. Good morning everyone, how are you? I'm Jana Ahmed Sadiq and today's topic is talking about fluid statics. First of all, fluid is a substance that can flow. This includes both gases and liquids. Air pressure, after we know about the fluid is a substance that can flow, and this includes both liquid and static and gases, and statics means it's like in rest. So for that, air pressure is defined as the amount of force acting per unit area. That means pressure is equal to force over area, or P is equal to F over A, capital letter F and over capital letter A. Now pressure is the ratio of the force to contact area that is perpendicular to the force. As we see here mathematically, the formula P is equal to force over area. Now here, if pressure increase, force also increase. But if pressure increase, area will decrease. The reverse thing also here. If pressure decrease, force decrease. If pressure decrease, area will increase. Okay. Now 1 Pascal. Pascal is a unit of pressure. Okay, 1 Pascal is equal to Newton over meter squared, or in another way we can say kilogram over meter per second square. Now here there is an equation to know or to how to solve and to use the formula of pressure. For example, an elephant has a mass of 4,000 kilogram. Each of its feet covers an area equal to 0.8 meter squared. What is the pressure from each foot? First of all, the given, what we have in the given, we have the mass, which is 4,000 kilogram, and we have for area is equal to 0.8 meters squared, right? Okay, and we need the required is pressure. So what is the solution? Okay, first of all, the formula of pressure is equal to force over area. But force here, we don't have force, we have mass. But the formula for force is equal to MA. That means mass times, mg. Mass times gravity, or it can be also F is equal to ma, because A is acceleration and G have the same unit, which is meter per second square, and here also meter per second square. So gravity we will take as it is like 10 meter per second squared, and we will times with the mass, which is 4,000 kilogram. Now what we'll make here, first of all, the solution is F is equal to mg, which is equal to 4,000 times 10, right? So now what we will have 40,000, and then we have 0.8, and pressure is equal to force over area. So here is the force over area, which is 0.8. Then we will simplify the last answer, the final answer, to be 50,000 Pascal. So this is the final answer for this question. Now let's continue with the other topics. Now let's continue with the atmospheric pressure. The atmospheric pressure is the layer, or the atmospheric is the layer of air that covers the earth. The pressure of the atmosphere is known as atmospheric pressure. Here, atmospheric pressure is varies with temperature, the altitude above the sea level, the impact of weather change, and the symbol of atmospheric pressure is PATM is equal to at the sea level is equal to 1.01 times 10 to the power of 5 Pascal. That means is equal to 1 atmospheric pressure. 1 atmospheric pressure is equal to 1.01 times 10 to the power of 5 Pascal is equal to 76 millimeter of mercury and 760 centimeter of mercury, and also is equal to 101 kilopascal. So this one was about some information about atmospheric pressure, and also there is an instrument that we can measure atmospheric pressure with it, like by barometer. Barometer is the instrument how to measure the atmospheric pressure, and there are different kinds of types of barometers, like for example mercury barometer and aneroid barometer, and also there's some uses of air pressure. Let's see together. Now let's continue with some uses of air pressure. Air pressure is widely used in drinking syringe, force pump, suction pad, lifting pump, and siphon. Now let's go to another topic, which is says fluid pressure. Fluid pressure is due to the weight of the fluid. Liquid is one of the state of matter which has its own different volume but not its own different shape. Instead, it takes the shape of the container. And there is a formula for fluid pressure, which is P, which is pressure is equal to density times gravity times height. So this is the formula for fluid pressure. Now let's go to see what fluid pressure is depending on. First of all, fluid pressure is dependent on the depth of the fluid. In the depth of the fluid. Okay. Then the second one is dependent on the density of the fluid itself. The density of the fluid. Okay. Then the third one, which is the acceleration of the object, or the acceleration of the gravity, I mean. The acceleration of the gravity. Okay. When pressure increases, the depth of the fluid also increases. And then when pressure is act equally, all the directions is act in all the directions equally in the container. And also pressure of the liquid does not depend on the shape of the container, as we said before. That it depends only on the depth and the density and the acceleration of the gravity. But about liquid, first of all, it doesn't have its own shape or its own different shape, because it's taking the shape of the container itself. So now let's solve some examples or some questions about fluid pressures. Now let's continue with the example of fluid pressure. What pressure is exerted by the water at bottom of a sea whose depth of 2000 meters? Take density of water, which is 1010 kilogram per meter cube, and gravity is equal to 10 meter per second square. Okay, now first of all, what is the given we have? In the given, we have the depth, which is the height is equal to 2000 meters, and in the density we have 1010 kilogram per meter cube. Density 1010 kilogram per meter cube. And what we have here for gravity, we have G is equal to 10 meter per second square. Now, the formula for pressure, for the fluid pressure, is P pressure is equal to density times gravity times depth. So that means pressure is equal to rho times G times height. Now we will put only the numbers in place of their symbols. Like for example, H is equal to 2000. So that means in place of H we'll put 2000, right? And in place of density we will put 1010. 1010 times gravity, what we have here, 10. So times 10 times 2000. Now pressure is equal to, it will be 1, 2, 3, 4, 5, 6, it will be 7. So 2.02 times 10 to the power of 7 Pascal. I think you can check it also by the calculator if you times all of them, or we can also do it right now. Let's make it here. What we'll make here, P is equal to G density times H, right? So 2000 times 10 times 1010, right? Okay, first of all here it will be 20,000. So 20,000, right? So 10 it will be cut it. Then we have this 10,000, I mean 1010. So it will be 1010 times 2000. It will be by 0, 0, 0, 0, 0. How many 0? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Again, by 1, 0. Here by 0, 0, 0, 0. Here it will be 2. Okay. Again by 0. All of them will be 0. Then by 1 it will be 0, 0, 0, 0, 2. So 0, 0, 0, 0, 0. Here it will be 2. And we have here 0, and here it will be 2. Now we will jump the decimal. It will be 1, 2, 3, 4, 5, 6, 7. So the answer at the last it will be 2.02 times 10 to the power of 7 Pascal. This is the final answer for this question. Now let's continue with the fluid density. Now let's continue by the fluid density. Actually, first of all, density is mass of substance divided by its volume. That means by symbol, rho is equal to mass over volume, where density by the Greek letter rho is equal to mass, which is the small letter m is for mass, and the symbol for volume is V. Now, density, first of all, is a scalar quantity, and it's measured in kilogram per meter cube. It's also measured in gram per centimeter cube. Liquids have higher density than gases because the particles are closed together in liquids than gases. Now let's continue by the relative density. Actual relative density is equal to the density of the substance over the density of water. And density of water is a constant, but the density of the substance will be divided with the density of water. Now we will see it together. Now let's continue with the relative density. First of all, as we said before, that relative density is equal to density of substance over density of water. Relative density, sometimes called specific gravity, and doesn't have a unit and has no unit since its ratio. Okay, the density of oil, here there's an example. This is example, okay? This example says the density of oil. The density of oil, which means the density of the substance, okay, is 800 kilogram over or per meter cube. Then what is the specific gravity, which means the relative density when compared to water? When we compare to water, that means water it have its density, which is 1000 kilogram per meter cube, and also it's given here in the question. So now what we will do, relative density, that is the specific gravity, is equal to the density of the substance, which is 800 kilogram over meter cube, over what is the density of water is 1000 kilogram over meter cube. Now, as we said before, that relative density does not have a unit, so that means kilogram times by kilogram, meter cube times by meter cube. Then what's left is 800 over 1000. 0 by 0, then 8 over 10, that means is equal to 0.8. Relative density of the substance, which is oil, over water is equal to 0.8. So that was about the relative density, the topic of relative density. Now let's go for the topic of Pascal's principle. I think you know the formula of Pascal principle, right? That's pressure 1 is equal to pressure 2. That means force 1 over A1 is equal to force 2 over A2. Pascal's principle, that it is P1 is equal to P2, which means F1 over A1 is equal to F2 over A2. The same thing if we make like F1 over P1, F1 over A1 is equal to P1, and F2 over A2 is equal to P2. If force increase, F1 increase, P1 increase also, pressure 1 increase. Area 1 will decrease if pressure increase or force increase. And here the same thing, F2 will, if it is increase, P2 the same thing, it will be increase. But if pressure increase, area will decrease. And the reverse thing, if area increase, pressure and force will decrease. The same thing. Like for example here, I will write it to make it easy for you. If we have in place of F1 8, for example, and we have in place of F2 4, we have in place of A2 2. So we need to find A1. So how we will do this one? First of all, 8 over A1, 8 over A1 is equal to 4 over 2. Right? We'll simplify it first. 2 by 4. Here it will be by 1. Here it will be by 2. So 8 is equal to 2, and here it will be over A1 and here 1. Crisscross, that means A1 times 2 is equal to 8. Then divide both sides by 2, here by 1 and here by 4. That means A1 is equal to 4. Can we check if this answer is correct or not? Yes, we can check. Like, for example, here, if we make the same thing, 8 here is equal to 4 over 2 here and over 4, right? So here by 1 and here by 2, here by 1 and here by 2. So that means 2 is equal to 2 is the correct answer, is correct, is true. That means P1 is always equal to P2. Always equal to P2. P1 is equal to P2. Now let's see an example to solve it, an question. Now let's see the example of the Pascal principle. Two pistons are connected together to make a hydraulic lift. The smaller piston has an area of 0.05 meter squared, and the large piston has an area of 4 meters squared. Calculate the force at the larger piston if the force on smaller piston is 400 Newton and the pressure in the lift. Okay, first of all, we'll see the pressure, then we'll see the force of the larger piston. Now what we have here? We have area 1 and area 2 and F1. Area 1, which is the smaller piston, and here is the larger piston. The larger piston and the smaller piston. First of all, the smaller piston is this, which is A2, and A1, okay, A1 is equal to 0.05, A2, which is 4 meters squared. Okay, A1 and A2, here we have F1, it will be equal to 400 Newton, right? Okay, this means F1. Now we need to find the pressure of the first one, the pressure in the lift. P is equal to F1 over A1 is equal to F2 over A2. So that means what we have here, 800, yes, over 0.05. Why 800? Piston has an area of 0.05. Maybe there's a first of all, F2 it's 800. Okay, F2 is 800 here, so that means 800 over 0.05. I mean F1. Why? Because 2 times 8, it will be 2 times 400 is equal to 800. You can see here also F1 over A1 is equal to F2 over A2, right? F1, what we have? F1 we have 400. Okay, A1 what we have? 0.05. And A2 what we have? It will be 2, or we can say it only 400 over 0.05. Yes, it's 400, right? 400, F1 is equal to 400. So that means 400 over 0.5 is equal to 800 Pascal. Okay, now for the second one, which is the force at the larger piston. If the force on smaller piston is 400 Newton, that means we have F1 is equal to F2 over A1 is equal to A2. Then F1 is equal to, F1, right? F2 is equal to, because we asked here larger piston. Larger piston is F2. F2 is equal to F1 over A1 times A2, right? So what we have here in F1, 400. So here it will be 400 over A1, which it was what? A1 0.05 times all of them A2, which is 4. So as the last answer, it will be 800 times 4. That means 32,000. 3200. Yes, because 800 times 4, so 0, 0, and here 32. So it will be 3200 or 3200. 3200. Now this is the final answer for force as the larger person. That means F2. Okay, and A1 we already know 0.05. A2 which is 4. F1 which is 400. F2 which is 3200, and P pressure which is 800. So this is the answer for this question. Now let's go for the application of Pascal principles. The application of Pascal's principle. Pascal principle is widely dependent on the hydraulic lift, and also hydraulic press and hydraulic brake system of the car. Brake system of the car. And this is the application of Pascal's principles. That Pascal principle is wider depends on hydraulic lift, hydraulic presses, and hydraulic brake system of the car. So that was everything about today's topic, that's fluid statics. Fluid statics, that's first of all atmospheric pressure or fluid pressure, then atmospheric pressure, then the density, fluid density, and also Pascal principles. In the second video, inshallah, we are going to make the total density, the total pressures. Like for example, PS is equal to P atmospheric pressure, like means atmospheric pressure, plus PGH. Density times GH. So that means total pressure is equal to atmospheric pressure plus the Guac pressure. You will know everything, and there is definition for the Guac temperature, for the total pressure, and for the atmospheric pressure. But in the coming next video, we're gonna to explain about this topics. Now I hope that you benefit from this video and gain information from this topic, from the fluid statics topic. And thanks for watching, thanks for listening. Goodbye.